um, are aware of the fact that I'm going to begin putting restoration agriculture into a context, uh, and it didn't just appear out of nowhere. And one of the most important contexts that we need to put it into is the context of nature itself and ecological systems, of which we're going to be designing ecological systems, and we're going to be living in them and working with them. And I found as I was so what's going to happen over the next 20 plus sessions, depending on how fast we can get through them. I'll be going through an entire college level curriculum on forest ecology. Obviously not as in depth, and you're not going to have to do any math like you would in college. But we'll go through all the general principles. And while I was putting this together, I realized that I couldn't remove forest ecology from my own personal context, and how I see ecology and ecological principles now is not the same as it was when I was a student, some 30 years ago. So this is going to be an introduction to forest ecology, but all through it, I'm going to be applying forest ecology principles to land management. And the picture right here of the farm, of New Forest Farm, that is, I eat, sleep, and drink and breathe, ecology principles on a daily basis. But that's not how I always was, and I tried to move the slide, Wayne, and it wouldn't let me, so you're going to have to go to the next one, if he's even still there. There we go. I grew up in north central Massachusetts at the tail end of the industrial boom. It actually was quite a collapse in the northeastern part of the region. It used to be heavily manufacturing. There was factories galore. It was on the Nashua River, which I don't know how many hundreds of mills were on the river. Everything from paper to carpets to a lot of metalworking, shoe factories, leather tanneries, weaving looms, all sorts of things. And these are some of the ruins that appeared during my childhood. I got to see them slowly crumble and fall apart. So I've seen a collapse of Rome. And if you look at this building on the lower left, that was one of my favorite department stores. There were 5 different stories, 5 different levels, floors in there. This was like before any of the big box Walmarts. The building has now been gutted and renovated. If you look at the picture in the upper left, there's a triple-decker apartment building. That's an apartment building that I actually lived in on the 2nd floor there when I was a lot younger. And that seemed to skip ahead pretty fast. But during that time, as I was growing up, I think I was probably 17 or 18 when I bumped into this book. Hey, who stole my screen back? There we go, thank you. I was 17 or 18 when I discovered Tree Crops by J. Russell Smith. It was originally written in 1926. And look right there, the small letter title, Tree Crops, a Permanent Agriculture. That's the first time I ever saw the words permanent and agriculture intentionally combined. So what Smith was proposing is that we grow tree crops to produce seeds for our livestock, because in his day, 40 to 50% of all annual grains were fed to animals, and so he figured, why cut down forests and plant corn to wash away the soil? Why not keep the forests there, have the seeds be productive, hickories, and now who's moving the slides? It's not me. Is that you, Wayne?
I'm not intentionally. No, I was trying to go to the question. Sorry about that. I'll be going backwards here. Which one do you want to go back to?
Go back to the first Red River, right there. Well, that's good. Either one is fine. The big game when I was little was to guess what color the river was. It seems to be that the pictures that you can find the most on the internet are the ones when it was red. My favorite color was blue, like the shirt I'm wearing tonight. And these were the industrial dyes and chemicals that were dumped into the river from all the factories, mostly from paper and leather dyeing facilities. And so on the one hand, I got to see the collapse of the industrial economy. I got to see all these factories fall apart into ruins. I got to see the area when it was probably at the peak of its pollution. There's some radioactive waste dumps that is still, every time you drive by it on the highway, you get the equivalent of a X-ray dose worth of radiation. There's several different Superfund toxic waste cleanup sites. The Little League field where I played baseball was built on top of a toxic waste dump. Several different whole entire municipalities have water that's contaminated from industrial chemicals. So I got to see this horrible destruction. And who's advancing slides?
I'm keep trying to scroll on the questions, and it literally goes ahead. Do you want to go back one more, Mark?
Go back one more, yeah. Because this previous one says the promise of restoration. You can see where early on I started to get this idea that systems can be restored. I saw this red river. I saw this blue river, green, orange river. I saw it clean up. It took, all kinds of citizen activism. It took a legal action, and it took a little bit of what I guess we would call ecological sabotage before they finally installed wastewater treatment plants. Well, then the industrial collapse, many of the factories just aren't there anymore. So I got to see the river restored. It came back to life. By the time I was a senior in high school, I saw fish swimming in the river again. When I was in first grade, one of my buddies fell in the Red River and got a rash, was hospitalized for a week, had a hard time breathing. Now, I tried to advance that, and it advanced, so maybe I do have screen control back again. So also, look at the foliage on the side of the stream. I got to see that when we stopped insulting the planet, it would actually restore. It would come back to life to a certain degree of health and vitality again. And so I was inspired. I first went to college, had a brief stint in the military, and went to college for engineering. I failed to thrive in both the military and in engineering, so I quit and went back to school at Unity College in Maine. Here's a little map of the campus. It's there are many more buildings now. All these buildings are new since I attended there. The only ones that were there when I attended were these the East View, West View, and the facilities shop. It, at the time, was the only college in the USA that was exclusively studies of the environment, and it actually still graduates more Maine forest wardens, fish and game officers than any other college in Maine. So I went to Unity College in Maine to study ecology. And it's while there that I started running into all these different texts. This forest ecology textbook is a newer version of the textbook that I used. So what we're going to be going through is this is the outline, Forest Ecology, 4th edition. We're going to be going through that outline in the next umpteen weeks, probably at least 20 weeks before we can plow through all of this. And I'll fill it in with all the other information from the other books as we go. So I went from being inspired by tree crops. Then I go to university. I start getting a college-level scientific education. And I found myself in a laboratory looking out the window, wishing that I was outdoors, because I thought ecologists, here I am studying ecology, I thought ecologists studied nature and all that. So I heard about the closing of the homestead laws up in Alaska. And so what I did is I went up, I claimed some land, and I came back and got my sweetheart, and two of us got married, and we went up to this place here. And I don't know if you can see my cursor, but if you go straight towards this pointy mountain in the center.
We can see a cursor, Mark. The cursor is really clear.
So you can?
Yes, we can.
Okay. So you go towards this mountain here, and you go around the base to the left of it, and you go around that buttress, and then you go around that way, and the next valley over, you cross through it, and then you go into the second valley over, was where our homestead was. So we're going to come in like right along here and be at the base of this mountain next. If the slide advances for me. There we go. That's Mount Sanford, 16,235. These are the Wrangell Mountains in the Wrangell-St. Elias National Park. It's the highest concentration of peaks in excess of 12,000 feet in North America. Then we would go around Sanford. This would be on our right. I was never able to get a photograph of this mountain because it was always in the clouds. I had to get this one off online. So then we would go to the left of this set of mountains and come up onto this green ridge. It seemed like a low green ridge, but this hill itself was actually 5,000 foot high. Stop off, get a little water, continue to the left, and then once we go across the left off screen, we enter into this valley. Whoop, why did it go two? We enter into this valley, and you see this cloud above these mountains here. That's a cloud that's almost always there. On the other side of that range is the Nebezna Glacier, which is the longest land-based terrestrial glacier in North America. It's some 75, 80 miles long. Always had a cloud on it. And so we would come off that ridge from that lake, around up through this valley, and then down this creek, zigzagging back and forth, and look at the forest cover. Then we get out here. This was all open. This is naturally open because what's fascinating about the streams there, the creeks, the smaller creeks, is the ground is permanently frozen. The rocks at the bottom would collect ice around it. And then what that meant is some of the volume of where the creek was would now be taken up by ice. So the level of the creek would rise. Then there would be more ice forms here. Then the creek would move this way. The more ice would form this way. And it would overflow back and forth and make terraces that looked a lot like Mammoth Hot Springs and stuff like that at Yellowstone. But this clearing right here, notice the square corner. Even up in Alaska, where I homesteaded, my wife and I were up there for 8 years. This is the view from my cabin window. Even up there, we witnessed people destroying their ecosystem in order to gain a livelihood. This guy down on the bottom of the valley here with these who cleared this whole peninsula of trees, didn't even insulate his house because he said he couldn't afford to buy insulation because he needed money for his snowmobile and gas for the chainsaw so he could keep his family warm. Weird reasoning, but that's like a miniaturized version of the state of humanity right now. Is somehow we have to figure out how to live on this planet without screwing it up, without destroying it in order to gain our livelihood. And that's why an understanding of ecology is absolutely critical for what we're going to be doing. It was while I was in Alaska that I started writing a book, brought notes to a friend of mine who was an English major. His name is Michael. He said, "Oh, that you don't need to write that book. That's already been written. It's called Permaculture. It's a photograph of first edition Permaculture Designer's Manual. It now has a different cover on it, and all that kind of stuff. But that was my copy right there. It was so long ago that everybody who'd ever taken a design course had their name and address listed in the back of it, and there was only a couple hundred people. That was rather difficult to get, and it wasn't any. It was. It's about the same price to buy it back then as it is now. So it's a real relative bargain nowadays. Permaculture, of course, it's a contraction of two words: permanent and agriculture, which is how I first learned it. I learned from this guy right here, Bill Mollison. He signed my diploma. This is the picture of the new cover on the designer's manual. And what really turned me around is when I heard a video from a global gardener. You guys can find it online somewhere, where he defined permaculture as an ecological design methodology where we create relationships between materials, plants, animals, and humans so that their function and their yield are optimized. That really got my attention. Then all of a sudden, I heard Bill Mollison say it in Australian, and I don't speak Australian. He says the aim is to create systems that are ecologically sound and economically profitable. And that sentence in white right here is what I'm all about. I spent my life working on. So what restoration agriculture is all about, and what we hope to be doing here at Restoration Agriculture Development and Eat and Seed is that we're not necessarily intending to train people to draw designs. We're not necessarily intending to train people to train other people, to train other people, to train other people. One of our goals is to get people trained and competent in living this way and actually implementing systems and doing genuine ecological restoration while simultaneously earning a profit, livelihood from that kind of restoration work. So, okay, so now I've got this end of industrial experience in my childhood. I've encountered tree crops by J. Russell Smith, and then I've gotten a education in ecology from Unity College in Maine. Now I'm steeped in permaculture. What I like about it is the ethics, and I'm always finding myself, I think this way. I think that whatever I do, I want to be taking care of the planet and its natural systems around me. You know, plants, animals, land, water, air. I always want to be doing what I can to help the planet to be a healthier, greener place to live. And I want to be helping people. I want to help people to feed themselves, to educate themselves. I want to, you know, help us with healing, with proper nutrition, etc. And the third thing here on the big ethics of permaculture, even permaculturists can't agree what this is. I've heard it everything from reinvest the surplus to fair share to I like the equitable exchange of ecologically produced surplus. We have to have some sort of distribution system where we're exchanging goods and services in a fair manner so that people's basic needs are met and people are actually rewarded for risk and innovation, and people are disincentivized, that's a word, I suppose, to not be a total parasite on the system. We need to somehow find some magic tension to create a new type of economic system that rewards behaviors that help care for the earth and care for people, and doesn't necessarily reward behaviors that are just purely parasitic or evil, for crying out loud. It was when I was in Alaska that this book came out, Permaculture, Principles and Pathways, by David Holmgren. Now, I hadn't realized how significant this was in my background thinking until I went through this again. It's David Holmgren who first came up with how we implement the ethics of permaculture is through a set of principles. And he outlined 12 in this book, Permaculture, Principles and Pathways. And I'll put them right here, and you guys, if you can, you know, take a mental picture of this, get a screenshot, or go online to just do a search for David Holmgren's book there, and you'll be able to go to the website, and there's a different icon and a different page for every single one of these principles. But we want to observe, imitate, and interact with nature. We want to capture and store energy, obtain a yield, and yield can mean many things, from food to artistic to industrial ingredients to beauty to spiritual renewal, etc. Apply self-regulation and accept feedback. And remember, no matter which end of the horse you're working with, there's nothing like a cold Kansas City sarsaparilla. We want to use and value renewable resources and services, produce no waste, design from patterns of details, integrate rather than segregate, use small and slow solutions, use and value diversity, use edges and value the marginal, creatively use and respond to change. So much of what I'll be talking about with forest ecology, I'll be dropping these particular principles in. There are certain ones of these principles that I think are more important than others. If you're going to actually get a piece of property and do a restoration agriculture, a perennial agriculture, farming or ranching operation, there are some of these principles that are more significant than others, and I'll emphasize those. The ones that I emphasize the most is observe, imitate, and interact. That one right there has been so missed by so many different permaculturists. Here's some permaculture principles from Bill Mollison. His first one was observe and imitate nature, interact with it, and accept feedback. Both of these guys are saying observe. than imitate and interact. And until we've done that, we've missed the boat. And that's the whole magical difference of restoration agriculture, is that it is directly observing nature. We're directly modeling after nature. We're not inventing new guilds and plant associations and whatnot. We're just replanting natural ecological systems. The one I like, of course, work with nature rather than fight against it, do the least amount of work, has the greatest long-term effect, understand and use natural succession, create integrated cyclical systems. All of this, all of ecology plays through me, it plays through those principles, and that's how I see the world, is through those principles. I really do. I'm a little bit surprised at how deeply they've kind of become embedded in me. Also, while in Alaska, I finally tracked down this book here, Water for Every Farm, the Yeoman's Keyline Plan. It's easily available from Acres USA if you want to get it. These days, it's pretty easy to get. It's not easy reading. It's rather challenging to read. The guy invented a whole bunch of new vocabulary that isn't consistent or compatible with a lot of civil engineering and geology and hydrogeology. But what I found the most significant out of that book was this little 8-step outline here, his keyline scale of permanence. And it's a decision, helps you with your decision making. It's like an order of operations based on how much effect it will have and how permanent it will be in the landscape. And let's take climate. Well, climate, we don't really have a lot of direct personal control over it, so we don't really want to spend a lot of time trying to control it or change it. We have to adapt to it and mitigate some of the effects of it. The land shape, if you live in the bottom of a pit, a low spot, geologically for miles and miles around, you're not about to turn that into a mountain. You can turn a mountain into a pit if you want to do mountaintop removal for coal, but that's not necessarily what we're going to do. So the land shape, we really don't have a lot of control over. But water, once we get to water, the pattern that you see in the background picture here, that pattern is based on just changing the farming, the direction of fields by running channels and mounds, by using a subsoil in a certain direction, and the whole pattern is to spread the water from the valleys out to the ridges. That water pattern right there, it's the least amount of work for the greatest long-term effect. That now determines where the roads go, tells us where we plant our trees, tells us where the buildings go, and it will help us with further dividing into smaller and smaller fields. And what I like about this here is last on his list is soil. Soil is easy to change. It really is. So many organic farming workshops, curriculum, etc., books that you go to, it's all about the soil, all about the soil, all about the soil. The soil's not as significant as a lot of organic folks would lead you to believe, especially when you start dealing with woody plants, which we are. I mean, you look at that picture here, there's a lot of different woody plants, and most everybody has seen trees growing out of cliffs. They grow out of cliffs just fine with no soil whatsoever. So, now why did the slide? There we go. Then eventually from Alaska, my wife and I and infant son and 2 dogs took all of our worldly possessions in a 20-foot trailer that I've been repainting 20 years later. And we moved to southwest Wisconsin, bought the farm. And the farm, when we bought it, was mostly abandoned cropland or overgrazed pasture. There's only about 3 acres of trees. They're about 14 foot tall, 3-4 inch diameter trunks at the biggest. And we've planted literally hundreds of thousands of trees in the past 20 years in very specific patterns. And so I've gotten to experience ecological succession. I've been able to live inside of a successional process of converting this back from degraded agricultural land into a mimic of its natural system of what was there. And I wrote a book about it. Yay, buy it from Acres USA. Please don't buy it from Amazon. It's real-world permaculture for farmers, permanent agriculture. Now, what also is significantly different about restoration agriculture is we're talking about the growing of staple food crops, our carbohydrates, proteins, and oils. Not necessarily making cool brick ovens or mud ovens or rocket stoves. We want to create context-specific solutions. So if we don't have clay to make a clay oven, we don't. We use stone instead. Instead of having a cute idea of capturing water off our roof, let's do a real design. We're doing real agricultural engineering here. If we have a 10 by 10 surface area that sheds water, that sheds 62 gallons of water in a 1-inch rain, how do I get that water from that surface to a storage facility? How big does that storage facility have to be? How many rains do we get before we start using the water? Where do we want to move the water to? And we design a system based on actual reality and then grow tons of food. And this picture in the upper right and the lower left, these are great examples of what I think everybody's permaculture yard should look like. We should have all these vitamin greens all over the place because that's the freshest food. We have the ability to have lots of labor, hyper mineralized, super nutritious produce, but this will not feed you. There's not enough calories, carbohydrates, proteins, and oils to keep a body alive. All of these people, when they go into their house, they eat food that they bought that was grown on farms. So we're going to design farms modeled after natural ecosystems that follow ecological laws and principles that are reality-based and context-specific. And this is the kind of the short that I put together here. It's written about in the book. Identify our biome and its keystone species. That right here, first step, we're just going to identify our biome, keystone species. We need to have an ecological understanding. So that's why we're going to be going through this program on forest ecology, so we can identify our biome. How does it work? How does it operate? And that's where, so step one, we're going to spend a lot of time, like 20 plus weeks on ecosystem mimicry and how to work within it. Then we do a little bit of earthworks and water management. We'll be establishing polycultures, perennial polycultures. Fences and roads and utilities and pipelines will follow the pattern of our water management strategy. We use agroforestry practices to transition from annual crops to eventual total perennials, or as many perennials as you possibly can. And then we just manage and manage and manage and manage. And the management is going to constantly change, because this picture right here with the pig, that's 15 years since it was a cornfield. So when I started, this picture right here was corn stubble. Then I got pasture reestablished, did the water management, started planting trees, added more trees and shrubs and bushes and vines and livestock, and started grazing it. So 15 years into the program, this is what it looks like. Our management is always going to be different. Now, if we don't have an ecological understanding, we may be surprised all of a sudden this year. It's like, oh my gosh, look what's happening to me. This is taken over, or that's taken over. My pasture is not as good as it used to be. But if we have a little bit of an ecological understanding, we know what challenges are coming toward us. And my biggest challenge right now that I knew was coming towards me was that eventually I would have to get into the situation where I've got to cut and cut and cut and cut wood. I didn't think it was going to happen in 20 short years. I almost can't keep up with all the wood I have to cut now. So these are some of the major biomes of the world. Some of the names we're going to throw out here: tundra, northern conifer forest, tropical rainforest. These are some basic terms in ecology that describe different systems, ecological systems, and we'll get more into this as we go. Rainforest, tropical rainforest, deciduous forest, grassland, savanna, desert, chaparral, scrub forest. Different regions with different temperature regimes, different moisture regimes, different bedrock, which will turn into a different soil type. All of them will support different species of plant life, which of course will support different species of animal life. And I apologize for those who are not in North America for the North America-centric perspective here. one of the things that you see here, I'm getting a little bit ahead, but I like this slide because of what it has here. One of the ways in forest ecology to categorize regions is by the forest type. And this map right here has forest types written down. If you say white, red, jack pine, forest type is all this brown. I don't even see any brown there. Where's brown? Then this turquoise spruce fir up in this region here, this region over here. Longleaf and slash pine further down south. Loblolly and shortleaf pine all through here. Oak pine, oak hickory. This is describing a region by the dominant trees, the trees that last the longest. They will chemically change the soil. They'll bacterially and fungally change the soil. And nothing will be able to live in an oak pine forest unless it's compatible with oak pine forest. If something from a maple beech birch forest will not necessarily survive in oak pine or white pine, red pine, jack pine, loblolly. So we need to have a little bit of ecological understanding on what kind of systems we're working with. This is one of the maps that I chose to work with, and where I'm located in southwest Wisconsin is right here between a mesic southern oak forest and oak savanna, and we'll cover that later on. I'm not going to spend too much time here other than the fact that we have archaeological geological eons that show that closed canopy forest, where the trees close the canopy, shut out light from reaching the ground, and there's no more grasses growing underneath, those have been in the minority historically for at least the past 90 million years or so, going all the way back a couple ice ages. I think 4 different ice ages. It's been savanna, except for pockets of forest. Here and down here were the only places where it was closed canopy forest since the last ice age. This closed canopy forest that has dominated so much of the eastern part of the U.S. is really a fairly recent phenomenon. There's lots of biologists that are arguing that it was because of the European colonization of the New World, that all the civilized diseases infected the Native American population, and the population of North America collapsed by about 50%, so the land managers were no longer doing regular burning and no longer managing the large herds of animals, and so the forest closed its canopy. So ecology, what is ecology? Ecology is it's the study of ecological systems, including the climate, the basic shape of a place, the vegetation that exists there. And if you think about the planet as we've got like this atmospheric air stuff going on, and we've got like this rock and soil stuff, that we've got earth and we've got air. Well, in between there's life. There's all kinds of plant life, there's all kinds of animal life and fungi, and there's some spores way up high and bacteria and whatnot up in the sky, up in the atmosphere. There's some way down deep into the soil and in cracks and crevices. But most of the action is in this thin layer up into the air, only a couple hundred feet, and below ground, only a couple hundred feet. That's the action zone of where all this life comes in between the air and the planet itself. And so ecology is a word actually that was it was coined in 1866 by this crazy feller here, Ernst Haeckel. He at the time there was a lot of scientific innovation going on. If you can imagine, 1860s. This is like some of the peak of the Royal Horticultural Societies around the world, and the peak of exploration of plant and animal exploration around the world. There were basically 3 different branches of biology. Morphology, like you can think things morph and change. It's the study of the forms of organisms. Physiology is the study of the functions of organisms, so it'll study muscles and bones and organs and metabolism. Then taxonomy kind of classifies and organizes different life forms according to their likeness. Well, what Haeckel proposed was the term oecology, O-E-C-O-L-O-G-Y, ecology, which is the study of our home and dealing with the study of the relationships of organisms. We'll be concerned with morphology and physiology, taxonomy, but most significant for us, because we're going to be creating complex systems, is that we're going to be paying more attention to the interrelationships between organisms and communities, groups of organisms. I'm already using language that we will will need to have in our toolkit. So ecology should be the study of ecological systems that are home to organisms. It's concerned with the organisms themselves, the biotic portion, which is all the living portion, the abiotic, which is the non-living, mostly the bedrock and dead stuff, and it's all during the solar energized zone where we're doing our serious business here. And so, basic ecology, the study of our home, the relationships of organisms, and of course, forest ecology. Well, what is a forest? Well, it's actually, believe it or not, even scientific definition, it's a fairly loose definition. It's a three-dimensional ecological system dominated by woody vegetation that exists in some sort of dynamic interaction with air, earth, matrix in the landscape. It's part of a layered structure. You'll notice that, yes, there are tall trees, but there are also medium trees and some shorter trees, and so on. Excuse me. Forests are systems of organisms living together with one another. Which is really neat is a lot of the popular literature on forest gardening talks about 7 different layers. There are 7 different layers. Well, a lot of people say, oh no, there's 4 different layers. What ends up happening is too many people start arguing about how many layers there are in order to be right or whatever, instead of understanding that there's all these different layers, categorizing them into neat little categories from the perspective of a guy who's trying to live in a system like this. Figuring out how to categorize them into neat little blocks and chunks, this layer, that layer, this layer, that layer, is a little ridiculous. What's more significant is understanding how this mess works. There actually is an amazing order to this system right here. It may look a little wild and woolly, and this is a fairly unmanaged system in this particular slide right here. But this is a three-dimensional, dynamic, always changing. It's never the same. Some people get this notion in their mind that a forest is a thing. It's not. This place, where we're seeing this picture right here, is changing through time. There's no one time that is ever the same again. A lot of these trees are going to be growing larger, taller, taking more shade. Some are going to start to lose vigor. Some are going to be dying. Some are going to be catching diseases, spreading diseases. Insects and animals, some are getting browse. It's constantly changing, and we have to figure out how to live within that dynamic system. So ecology is studying relationships between organisms and systems of organisms, and the forest is something with woody plants. We're doing forest ecology. We're going to be doing the study of complex systems of woody plants in various different configurations. There's no one thing that is like, this is a forest. It's a fluid continuum, and actually starts with bare rock. I have some videos that we'll be having on our private member pages pretty soon that show some early succession on a rock in northern Lake Superior. We can start with a rock and over a period of time end up with a system that looks just like this. It's never the same year after year after year. So we're involved in the study of forest organisms, their response to physical factors, environmental factors, functional relationships between them, between the woody plants and animals, between animals and animals. We're studying the dynamics of the whole system. We're studying the dynamics of groups of organisms within the system, and so on. And it's fun. It actually is. So one of the ways that we already alluded to earlier in one of the previous slides is many forests are designated by type. And I know a lot of the mid-Atlantic, it's classified as oak hickory forests. There's a lot of dry pine forests. This is a slide here of dry pine forest. A lot of red pine. I don't see jack pine in this particular photograph. Now, you think about it. Pine isn't the be-all and end-all of this system here. Pine is the organism that has been there the longest, will be there the longest, and currently in this phase, it's dominating the site. There's a layer of needles that are driving the soil life and decomposition cycle. There's all kinds of exudates that are just oozing out of the needles. When the rain washes on it, there's different chemicals that are going into the soil. This site is totally being dominated by red pine, and it's that red pine, dry pine forest is the forest type. And then within a forest type, there are often individual stands. So this here is a forest stand, is a local subcommunity within the forest type. So within this dry pine forest, this is up in northern Michigan, within this jack pine, red pine area, there's a stand of white pine. And there's my wife down on the lower left here. These are some rather large trees. These are up near Copper Harbor, Michigan, on the Keweenaw Peninsula, Upper Peninsula, Michigan. So the stand is a subcommunity of trees within the forest. There's enough of a uniformity going on that you're walking through the woods, all of a sudden you go, oh, wow, here's a stand of aspen, or here's a stand of beech, or here's a stand of pine. Overall, it may be in pine forest region, or it might be in northern hardwoods region. Then there's a stand of red pines, or a stand of red oak, a stand of white oak. So a stand is a subcommunity. We can study the subcommunity. We can study the whole region. There's different degrees of understanding that we can bring to this. I'm going to zoom out a little more even further. So we talked about the forest type, and we talked about a forest stand. Well, now we can understand things at the ecosystem level. Let's think about the landscape level, landscape ecosystem. Think of the Front Range of the Rocky Mountains. Think of the Serengeti. Think of the Canadian Shield boreal forest. It's a lot larger, distinct region. One of the things about these various different categories, they are size-wise different, but they're distinct in that you can tell when you're in the Serengeti because it just looks like this. There's some places that are flatter, some are hillier, some are drier, some are moister, but you're in the Serengeti. All of a sudden you move out and it's like, this isn't the same anymore. So there is a distinct difference. Now within the Serengeti, there's going to be different types, forest types. There'll be this kind of acacia or that kind of acacia. Well, then within this acacia forest area, there will be a stand of river fig. There'll be a stand of whatever other trees that there are. So we can study the landscape level ecosystem. We can study the forest type. We can study the stand level. We can study individual plants. And what we want to do as land managers is we're going to be doing all of the above. We need to have an understanding of all of these, because if we're going to plant pine nuts, well, we can't necessarily grow them out of context. If we do, we have basically a hydroponic system where we have dead, sterile soil, and we're responsible for all the chemistry that these plants need in order to survive. But even if we're doing that, that pine orchard exists in a context. That stand, that orchard exists within a general region of forest type, or ground cover type, which exists within a landscape ecosystem, wherever it might be, the Missouri Ozarks or whatever. So we go bigger or smaller. Go ahead and advance, please, slide. It didn't. There we go. So I was going to do more. And then there's people who it's not people, it's just a different way to understand. So at the landscape ecosystem scale, we can understand, like the Serengeti, for example, by the biology that's in that area. You know, you'll find the elephants and the zebras and the wildebeests and all this kind of stuff. Well, once you get out of that, you know, eco region and you're at a different place, there'll be different plants, there'll be different animals. So understanding ecosystems from the biology side is the bioecosystems approach. And there are others who emphasize the significance that the geology itself has on the region. And one of the places that really was clear to me not too long ago was in southern France, where the bedrock was all dolomite limestone. It's very high calcium, and if you can't survive in a high calcium, high magnesium environment, you're not there. So everything was driven by the geology itself. Sometimes there's isolation. The Ngorongoro crater in Tanzania, it's a caldera, collapsed volcano cone that the animals can't migrate out of. They're in there. They're stuck. They can't get up and down the walls. And that's a geographic limit, and that system is only that big, and that's totally characterized by the geology, the geography of that area. So we can do the geoecosystems approach and understand the ecosystem by its major geological geographic features. We can do the bioecosystems approach at the landscape scale, at the forest type scale, at the stand scale, at the plant community scale, at the individual plant or animal scale, and so on. And if you look at this right here, this is just a classic. We can look for everything from at the universe scale all the way down through the ecosphere, which is all of the parts of planet Earth that has anything alive on it. Go to our regional ecosystem, your local ecosystem, down to like your forest stand, to the single organism, white pine tree, to an organ within a white pine tree, needles, to cells within the white pine needle. Is it a parenchyma cell, a meristem cell? Is it a tracheid? Is it a this? Is it that? Smaller and smaller. So this is just different levels of understanding. And what we want to do as restoration agriculture practitioners is have an understanding of all of these levels. We need to have some understanding of cellular biology and some understanding of how our regional ecosystem works, how the whole ecosphere works, because what ties in up here is weather and climate. So just understand we're going to be zooming in and zooming out, and zooming in and zooming out, instead of freaking out because, oh, wait, we're supposed to stay at this level here. We're Renaissance people. We have opened up our field of understanding so that we can understand the whole kit and caboodle, and we will focus in on whatever level we want when we need to. Some of the characteristics of the landscape scale ecology understanding is we understand that no matter what the system is, no matter what plants are dominating that site, whether it's in a desert or a tundra or a savanna or a forest, that it's multi-layered. There's all kinds of different layers thrown in there. We already talked about that a little bit. And what's fascinating about a complex system is if you take, and I'll show some pictures later on, if you take 5 different species that in nature would appear with one another repeatedly over time, that's a plant community where they all live together with one another. Permaculturists would call that a guild, but in ecological terms, that's a community. If you were to take this plant community and plant it in a golf course and surround it by, Kentucky 32 blue stem, whatever it is, and then just keep it mowed, that tall forever and ever, and give it all of its fertilizers, it's going to basically act like the 5 different trees that you put there. It's kind of all by itself. It's not really interacting with a whole lot. Once you get to a certain scale, all of a sudden there will be emergent properties within these species. It will be the same species over and over again have different emergent properties. And what's fascinating about this, if I say the word apple orchard, you guys get a picture of what an apple orchard, most people like have an apple orchard would look like. Apple trees, grass underneath, that's about it. That's a very simple system, which is the apple trees, and it behaves in a certain way. It's fairly predictable. Once you have two different species in that orchard, it's going to act like a completely different bird than just one species, apples. You start adding 3 species, 4 species, behaves totally different. And those different ways of behaving, those are the emergent properties that are appearing. And it's almost like we have to manage the emergent properties more than we manage individual species. Like what's going on in my apple orchard right now, I can't really call it an orchard because it sure doesn't look like one, is it's behaving differently than any of the books have ever told me how, you know, an apple production system should behave. Same with chestnuts, same with hazelnuts. So these emergent properties are really really significant. And part of what causes these emergent properties is ecosystem structure. We have vertical structure, it's different heights of things that are in there. That affects how the whole system behaves. Then we have species composition is different. You add one more species. If you have like 1 and 1 is 2, but actually, you know, 1 times 1 is 2. Then, you know, 1 times 1 times 1 times another one times another one. You start ending up with these numbers of different interactions between them. This can only interact with this. This can only interact with this. Now you've got 3. This can interact with this. It can interact with that. It can interact with both of them. This interacts with this. This interacts with that. So this immediately goes from, you know, 2 to 9, and so on and so on. The complexity is what creates some of these emergent properties. And so it's the structure and the species composition that really affect the emergent properties. And I'm just going to go quickly through. These are the oak savanna species that I started with, that yellow map I showed you earlier, and in the book Natural Communities of Wisconsin. And so all these different species are the species that occur on my farm. I've planted all of these. I've planted oaks, chestnuts, beech, apples, hazelnuts, plums, cherries, peach, apricots, raspberries, grapes, currants, blackberries, fungus, forage, animals. And if I arrange them spatially different, if I put all in the same place, if I isolate them, they behave differently. Same species, different behavior, which is really amazing. Chestnut trees, for example, behave radically different when they're a row on either side of an annual crop. And these are collard greens and lacinato kale in this particular picture. This is a rather simple system. It's got a row of chestnut trees. It's got an alley of an annual crop and a row of chestnut trees. Very simple. Much more complex than just a chestnut orchard or just a produce field. What we end up with is a term that we're going to be using more and more because the scientific community is using it more and more when describing agroforestry systems, and that's called land equivalent ratios. Is if you have chestnut trees, these are spaced as wide apart as they should be for when they're 30 years old. They'll barely touch in the middle, and so then that'll be like the optimal spacing for chestnut trees, big, huge chestnut trees. Well, in the meantime, we cash flow with short-term annual produce in the alleys in the middle or small greens. And so we don't get a complete acre of produce, so we get a little bit less than a full acre of produce. And then these chestnuts aren't fully mature yet, so it's a little bit less than a full acre of chestnuts. So they got a little bit less than an acre and a little bit less than an acre. Actually totals up to more than an acre. We have a land use equivalent ratio, a land equivalent ratio that's greater than if you had had it just in chestnuts or just in produce. And this is the same species, different cropping system. These are hazelnut and apple and chestnut and cereal rye that's growing in between here. This behaves different than if you have produce in between. And when you put the different species, if you put chestnut in one row, and apple in another row, and hazel in another row, and cherries in another row, it behaves differently than if you put them all in the same row. And this is, I think this is a realm of exploration that we all need to really dive into. Which arrangements are easiest for us to work with? Which arrangements get us the best return for our time and our highest return on investment income? This I like this right here. I wanted a windbreak behind the house, and since we moved from Alaska, we wanted spruce because we missed the spruce trees, and we interplanted with blueberries. But now the blueberries, we need to give them light, so we prune the spruce trees, and the blueberries have light. This system behaves differently than if we had an overstory of spruce thinned with blueberries underneath it. These emergent properties, these systems behave differently by spatial configuration and by species composition. Here's a clump. This is a circle of all of those listed oak savanna species in a 15-foot diameter circle. It's all mulched with oak chips and it's growing stropharia mushrooms underneath it. That behaves totally different than all the other systems. And yet it's the same species. And so part of what I wanted to emphasize here is that easily we run right into all these ecological principles going on our farm, live action. We're immersed in them. And if we had no understanding of what's going on, this would confuse most people, but this is highly ordered, it's predictable, it's measurable, and we can understand this, and we can work with this, and we actually get yields. One of the things I took this picture for, that right here, we get chestnuts and cherries and apples and hazelnuts all in the same row. What we do have underneath the chestnut, there's competitive effects, and there's hazelnut under here. It's these little rounded leaves. It's got hazelnut under there, but they don't seem to be thriving all that well. But if a closer look, you just lift up these little branches. The hazelnut bushes have been stunted and runty. They're loaded with hazelnuts. So with the structure and the function within these ecosystems, with the plant communities that we're working with, they will behave differently depending on the context that we put them into, and they will behave differently. Here's another example. This is more chestnuts and apples planted really close together. So now it's closing a canopy, and you notice in the middle we're starting to lose the grass. The grass is starting to die out, so we're losing that part of the productivity of the system, but we're getting a different part in that eventually we can be growing mushrooms under there. And matter of fact, that's where we cut a lot of mushroom logs from. We haven't gone so far that it's so shady that it's now closed canopy forest, no grass underneath, same species. You can obviously see that there's different behaviors. These species are behaving differently based on their context. And I wanted to show those pictures just to let you know that we're not talking about a static thing here. It's constantly changing. And what's interesting is about ecosystems is that they are managed by disturbance. Somehow they are interrupted and they're stopped, reset periodically. And here's one of our disturbance regimes, as we're grazing in the chestnuts and apples with cattle. So grazing has been a big disturbance through time. So hasn't windstorm, and so hasn't fire. This is a big fire down in, I believe this is down in Georgia or North Carolina, wildfire. So animal impact and fire has been changing ecosystems forever. We're going to keep those tools in our toolbox in order to manage farms that will look like this. So that was an introduction to some of the basic terms that we're going to be dealing with. What I'm going to do is I'm going to list all of the most significant terms that we need to know, just like a little vocabulary list, because as time goes on and we work through this, we're going to be saying these words over and over and over again, and you'll want to understand that as we go. So, questions?
Mark,
yes, sir.
that's awesome. I think we do have a few questions. I don't know if you looked them over there. I actually wrote it down. I don't know what's happening. Every time I went to the question thing, it would move a slide, so I stopped going over. But I'll just throw out a couple that we had here. Back to your very first. It says, have you ever seen the laser rust remover? Any substance to it, or is it bogus? That was back to your very first.
Yeah, I have I've not seen that. What's interesting is, and you can attest to this, Wade, I really don't spend a lot of time on the computer. I spend my time outdoors interacting with nature, and so I haven't seen anything about a laser rust remover, no.
All right, okay. And there's a last one here. I'm going to get to it last, but suggestions for eradicating mare's tail in a field that has been in CRP for the past 15 years, from Patrick.
One of the first of all, what is the plant mare's tail? Because mare's tail, what we end up with is a challenge called common names, and the flower Jacob's ladder. There's about 15 different species of plant that somebody down here calls that Jacob's ladder. They call this Jacob's ladder. I have no idea what he means by mare's tail. If you're in the southeastern U.S., south central U.S., I think I know what you're talking about. It's this tall, weedy thing with like these little fuzz all over it. One of the things for eradicating mare's tail is, and it's any kind of management that we want to do on a species, we have to learn a little bit about its life cycle. And if we know, if it eats root reserves, it grows up and it's about to flower, that's when it's invested everything and it's just about to flower. As soon as it starts to flower, you go mow it and you really drain the root. And then it tries to come back again, it'll come back smaller. Just before it goes to seed, you mow it again. That's one way to do it, so you constantly harass it that way. Well, then you find out what soil type does it prefer, and it usually, a seed, for example, it will only sprout if certain chemical, moisture, and temperature conditions are met. So if you are creating conditions that favor the sprouting of mare's tail seed, figure out how to not do that anymore. One of the reasons why mare's tail comes up is because a place is overgrazed. The animals stay there too long and they eat down their favorite grasses and they don't eat the mare's tail. And the mare's tail proliferates, it sets seed, and it keeps coming up, and the livestock eat the good stuff, and it just goes eventually to mare's tail and thistles and so on. So those are some of the conditions that are creating favorable conditions for mare's tail, so figure out how to not do that anymore. And a trample graze with a mob, be more effective at breaking that down. They'll eat some because they know that they're coming through fast. They'll eat a little bit, and then you follow with a finish mower, and you start clipping that. I do a lot of that kind of treatment with various different Canada thistles, and burdock is one of my most persistent biennials that keeps showing up. It's a management issue that caused the proliferation in the first place. I also have a lot of poison parsnip. Management issue caused the proliferation in the first place, so figure out how to not do that anymore, and figure out how to interrupt its life cycle and keep knocking it back and knocking it back. Don't let it set seeds. And then you can also modify the soil conditions to make it so it's not favorable for that particular plant. And that's a multi-pronged approach to it.
Awesome. And he was in central Illinois, so fairly close to you there with his question. Couple people said, thank you, you're blowing my mind and with this presentation, awesome.
Who grew up in Groton? Sam Palmer, oh my goodness.
Yeah, Sam Palmer, Groton, that's right. A question about nurseries. We're getting close to the timing, and we want to be respectful of Mark's time as well as all of yours. It's a great question, by the way, John. And I'm sure that over the course of these next 20 weeks or so, Mark's going to talk some more about that. He asked about how do you start a nursery specifically, how to get the materials and such, and if you can skip steps in buying seeds or plants from people like yourself, like New Forest and such, which obviously, yes, you certainly can buy seeds and plants. But I'm sure that maybe rather than just answering that specifically, Mark, you're gonna deal with a lot of that over time here. So.
We will, and actually I think we should probably specifically do one on nursery establishment and nursery networking, because this group right here, because of our dispersed nature and the fact that all of us live next to some plant somewhere that's just amazing, we need to spread those genetics out, recombine new genetics, cross-platform back and forth, and all start selling one another's material locally from our own point of sales.
And by the way,
As far as
oh, go ahead, sorry.
I was just going to say, and then about how about maples in the mix? We'll get to maples, especially later on as we talk about succession, which will be another couple presentations down the line. Because what's happening right now in much of my system, if you look at the slide here, the areas where they have the largest trees that are now closing the canopy, I'm getting shady enough conditions and enough of the soil life has changed from bacterial to fungally dominated. Now I'm getting a lot of maples coming in. They're a late successional shade-tolerant plant, and if you try to plant them right out into a cornfield, they don't really do all that well. So you want to have some early successional stuff to go through first, you know, and if you're going to be growing in the maples region, you go ahead and you plant chestnut and hazelnut and cherry and apples and plums and raspberries and grapes and mulberries, and give it 10 or 15 years. And then start putting your maples in there, and then they'll grow. They'll just take off. I got maples that grow, 2 feet nowadays, whereas before they wouldn't have hardly grew at all.
All right. Well, I think we've covered most of the questions here. I'm just going to say that again, folks. We have a Facebook group that I'm actually joining most of you to. I've got up to about 150 of our 400 members that are joined. I'm going to continue that. If you really want to get in quicker, just send me an email, and I'll make sure to put you in. I'll have everybody in before the weekend. Please go into that site and interact with each other. Ask questions of each other like this. Mark and I and other of our coaches and teachers will be in there also. We'll answer we'll help to answer questions if we can on that site. That's what we're going to use for interaction, that private group, because the whole idea here is just to help you folks and interact. And Mark just said it. The more we share about what's unique to our locations, and the more we can help develop all kinds of strategies that will work. So, Mark, you have anything else to finish with?
How about this slide? If we'll advance to the next slide.
I'll see if I can.
Yeah.
There we go.
There we go. Yeah, just quickly to address the person who's in a mixed grass prairie. Does the savanna, a forest ecology concept still hold? Well, yeah, it does, because a prairie isn't a thing. A prairie is a phase. It's an early successional phase that has a disturbance regime that keeps it in grasses. And so if the disturbance regime were to change, the characteristic of that place will change over time. So prairie isn't a thing. It's a part of this ecological continuum, and its disturbance regime either keeps it in grassland or allows it to go further. Like the previous picture, I was saying I've got the places where maples are coming in. Someone in a grasslands ecosystem, if they allow it to or push it ahead of time, it'll move into the more forested system. So it totally applies. Thank you for your time, everybody.
Yeah, thanks, everyone. There will be a replay up of this probably by early Friday, maybe tomorrow. Again, all of you are members. You can go in and look at those. If you're not yet, I'm going to show quickly a slide here. I'm going to escape from this one real quickly, minimize my screen here, and show one quick slide right here. I think you're seeing this. Stephanie, is that right? You're seeing the slide? Yeah, it just came on. This is actually an opt-in form that is on the site. I'll send this URL out. If anybody else you know that wants to get into this free to our Economic Action Team program, this is where they could just create an account for themselves. Anybody that registers for the webinars, I'm going in and creating accounts for you. So if you registered tonight and you were here tonight and you weren't already in the community, you'll be put into it tomorrow. Again, we've gone from starting this up just 4 weeks ago to about 400 in the community now. We are doing 2 nights a week of live presentations. We'll start moving to 3 and 4 nights a week within the next month, and having other kinds of topics. Please suggest topics to us. Please come back again. Mark, thank you so much. Mark will be back next week. And everybody have a great 4th of July. Think about this planet and think about helping each other. We appreciate all you guys. Talk to you later.
Remember, ye who goes forth on the 4th with the 5th may not come forth on the 5th.
Okay, got it. All right, everybody. Adios. Talk to you later. Bye-bye.